This is Ritesh Srinivasan and welcome to my channel. In this video, let's look at BERTopic. Okay, so what is BERTopic? BERTopic is a topic modeling technique which leverages transformers and something called as class TF-IDF to create dense clusters, allowing for easily interpretable topics while keeping important words in the topic descriptions. So in this video, we'll look at what is BERTopic, what is the algorithm, right? We'll look at a demo on the arxiv dataset. We will also look at how we can use custom embeddings, custom dimensionality reduction and clustering on the same dataset, right? And why should we use BERTopic instead of say LDA? And finally, a little bit about installation notes. Okay, so let's dive into the algorithm. Okay, so if you look at the algorithm of BERTopic, so this is actually created by a person called as Martin. Okay, so if you look at the algorithm, the key idea over here is that you have documents, okay, from which you want to identify topics. So what you can do is that you can use transformer based embeddings, usually BERT, to actually get embeddings for these documents. So once you get these embeddings for these documents, text documents, you can actually then cluster documents into semantically similar clusters. For that they use UMAP, which is a dimensionality reduction on the embeddings, and then hierarchical DB scan for clustering these embeddings. Once you get these clusters, then here they apply something called as c-TF-IDF or class based TF-IDF and maximum maximize candidate relevance, okay, with maximal marginal relevance to actually get important words or topics for each cluster. So it's a three-stage algorithm. You first embed documents, extract document embeddings with BERT or any other embedding technique. Then you cluster document using UMAP and to reduce dimensionality and hierarchical DB scan to cluster. And then you create topic representation using c-TF-IDF and improve coherence and diversity words with maximum marginal relevance. Okay, so I wouldn't go into the default models which are available over here for BERTopic. You can look at this page, but BERTopic makes use of sentence transformer models, and there are two default models over here to get the embedding for a document. Okay, there is also multilingual support for 50+ languages. Okay, for clustering document, as I said before, it makes use of UMAP because it for reducing dimensionality because it preserves both local and global structure, and then they use hierarchical DB scan. Okay, now this is the important part where they from each cluster they try to get the important words, right, or topics. So how do they do it over here? So what they are doing over here is that this is a slightly modified version of TF-IDF. So what they do is that each cluster is converted into a single document instead of set of documents. So you have clustered the documents. So each cluster is then converted into a single document. Then in that cluster, for a word, they extract the frequency. Okay, how many times this word appears. Okay, that is this thing. Okay, then what they do is that is the term frequency representation. Okay, then what they do is that for the IDF, they compute it like this. Okay, what they do is that they take log of 1 plus, where A stands for average number of words per class, okay, divided by basically, right, the frequency of word X across all classes. Okay, so that is your inverse document frequency over here. So they have added a 1 over here so that these values will always be positive. So this is the class based TF-IDF representation or c-TF-IDF. So this is the IDF and this is the term frequency which is class based over here, and they multiply this to get the class based TF-IDF which gives the important words in this particular cluster which can represent your topics. Then they use maximal marginal coherence to find the most coherent words without having too much overlap between the words themselves. Okay, so this results in the removal of words that do not contribute to a topic. Okay, so you can have same set of you can have similar words describing the same topic, right? So you can have overlap of these words. To remove that, they use maximal marginal relevance. Okay, so this is the simple technique by which you can actually do topic modeling. Okay, now let's go to a demo of it. For the demo, what I've done is that I have actually used the arxiv dataset. Details can be found on Kaggle over here. I'll put the link to this dataset as well. From this dataset, I look at abstracts, and this is some pre-processing. I'll not go too much into detail. Basically, I pull abstracts from 2020, 2019, 2018. And then you see, this is how the data frame looks like. There is a title, abstract, and categories. These are the various categories. I am pulling computer science publications over here, and I get a total of 23,665 documents. Okay, but what I did was that I tried experimenting with 10,000 documents, 5,000 documents, and I got some kind of error in this BERTopic in the UMAP library for dimensionality reduction. So I'm trying out over here with just 2,500 sentences. So here I've reduced the total number of sentences or abstracts, basically abstracts, okay, from your 23,000 to nearly 2,500. Then BERTopic is simple over here. You have to just import BERTopic, right? And you have to create a topic model. Okay, I am using calculate probabilities is equal to true because I want to visualize per document what are the topic distribution. Okay, then all you have to do is that you have to call topic model dot fit transform, and you send your sample basically sentences, basically abstracts over here. Okay, list of abstracts. Okay, and this will actually now do the topic modeling, and then it will generate the topics. Okay, it is as simple as this. You create a topic model object like this, right? And then you do a fit transform on your this thing. This uses default sentence transformers, the default configurations. Okay, and then you will get the topics as well as the probabilities of each basically each document over here. In our case, it is abstract. Okay, now you can do topic model dot get topic info to get the list of topics. So this is how it looks like. Okay, so the -1 or the 0 topic actually stands for outliers. That is what was written in the documentation, and these are the different topics. So here we have close to 50 topics, and these are some of the words which are present in those topics. For each topic, you can get what words are important. For example, for the first topic, you can get like this. For topic 38, you can get like this. These are the words which are comms frequency microprocessor for this particular topic. You can also visualize the c-TF-IDF scores for each topic. So for the top 10 topics, the scores are being visualized over here using bar chart. So here you can see that for the topic 0, quantum is the most important word. For the topic 1, images, right? For topic 2, wave, and so on. Okay, so in this way you can interpret what are the words which are present in the topic. You can also visualize the topics. Okay, so for this what is done is that using the c-TF-IDF scores, again using UMAP, you can do dimensionality reduction, and then you can visualize like this the inter-topic distance, for example. And when you go and click on a particular topic, you can see what are the important words over there. For example, topic 47 talks more about network, mobility, mobile. So papers or abstracts related to these topics. Say for example, topic 44 is about deep learning, machine learning. Okay, another topic is about matrix factorization, things like that. So here you can visualize what are the important words for topic and how these topics are distributed. So here there are a lot of overlap between these topics because these talk about machine learning and your vectors and image reconstruction. Here you have deep learning, a little bit of genotype, some overlaps over here, right? So this kind of shows how these topics also overlap, how these clusters overlap. Okay, you can also visualize the clustering, the clusters using a similarity matrix. So here it internally uses topic embeddings, and here you can see that you can see which clusters are slightly related to each other. For example, here you can see that one of the fourth cluster is related to, or the fourth topic is related to the first topic, and so on. So if you see quantum word keeps repeating over here, so it has a high similarity, right? So these blue ones are high similarity ones. For example, over here you have something learning classifier, and there is some between these topics, some overlap between these topics or similarity between these topics. Okay, so this is the heat map visualization. This library also provides a hierarchical visualization of these topics, right, which is this kind of a dendrogram visualization. Okay, in this way actually you can interpret the various topics. Now the question is that if you want to visualize the distribution of a single topic, a single document, sorry, okay, so for the first document you can visualize the distribution of topic probabilities, something like this. Okay, so the first document is more about some kind of epidemic, it more of topic 28 and topic 15, but there is also a lot of other topics also present within this document. Okay, now if you look at another document over here, it kind of shows as the probability of 1 and it belongs to this topic, some numerical method. Okay, and another document example is shown over here. This talks about the population genotype. So if you see over here, some documents just have one topic, whereas some documents have a mixture of topics. Okay, that's the kind of conclusion which you can see over here. So in another document you see it's a kind of mix of topics. Okay, basically the probability of topics over here. Okay, so this was about how you can use BERTopic to actually perform topic modeling on a set of documents and how you can interpret those topics. Okay, now in the latest release of BERTopic, they've also provided an option whereby actually you can try your own basically dimensionality reduction. For example, here I am using PCA, so you can try that. Okay, you can also use your own clustering algorithm over here, for example k-means, and you can now instantiate a BERTopic model using custom dimensionality reduction as well as custom clustering as well as the embedding model. I have changed over here. This was allowed before also. So what I've done over here is that in sentence transformers, see basically the embedding model to generate the embeddings for a document supports all models which are present within say sentence transformers, right? So when I looked at the sentence transformers page, there was this LNAI Spectre, which was a model for sentence embeddings for scientific documents. So I thought, let me try that over here. All right, and I wanted to try k-means and dimensionality for dimensionality reduction. Instead of UMAP, I am trying PCA over here. All right, so I instantiate a new topic model with this, and then I call fit transform on my same set of documents. So here when I do this, I try to print the topics over here. You can see that some words like we and of are coming over here. So some kind of pre-processing may be required when we are using this set of a combination. But then if you look at the topics also, you see a lot of words over here are topic 0 is actually outliers over here. In the previous case it was -1, right? So here topic 0 we can consider it as outliers, but if you look at the other topics you can see the words over here. But again you see that these common stop words are coming over here. Probably a deeper investigation is required over here, like why stop words are coming as top words within a topic. Probably this k-means algorithm may not be better in clustering over here, or maybe if you pre-process and remove some of these words before giving it to sentence embeddings, it might give good results. And even if you visualize the topics over here, some are good, but then some are like kind of overlap, may not be as good as the previous case of in the previous case the topics were much better. Here it's more kind of see over here you have words like the, of, and, on. I am not clear why it is actually picking up these stop words a lot over here, but this is the case which I observed when I used your k-means and PCA over here when I did this thing. Probably what I realize is that maybe once we do the computation of the TF-IDF or class-based TF-IDF, I think there some kind of stop word removal needs to be done. Maybe it's not done. I'm not sure about it. Maybe that's the reason why stop words are coming over here. But this is how you can also call a customized embedding as well as a customized dimensionality reduction as well as clustering model when you are creating BERTopic. Okay, BERTopic based topic modeling technique. Okay, so you can see even this is a lot of similarity between all the topics. So the clusters are not clear, or yeah, that's the case which you can observe over here. A lot of overlap between topics, right? Yeah, and you can also visualize using hierarchical clustering. And one thing which I found out is that when I'm trying to print the probabilities basically for a single document, there was an error. Okay, which came up when I tried to print the probabilities. So maybe this is the latest release, so maybe there are some bugs which are present over here. Okay, but the overall idea over here is that you can actually use embeddings, contextual embeddings which you get from BERT or transformer based models, and then cluster those embeddings to cluster the documents, and then use something called as class based TF-IDF to find the important words in a particular cluster which represents certain topics. And then you can also use maximum marginal relevance to actually find out similar words, and then you get the best possible words for a topic. Okay, that's the idea over here. Okay, so then the next question is, like, you have these traditional LDA, NMF, these kind of algorithms, right? So why BERTopic? So I went to their GitHub and somebody had asked this question. So here is the answer from the author himself, Martin. So what he says is over here is that every topic model has its pros and cons. Okay. What is the advantage of BERTopic is that it leverages contextual embeddings which can capture contextual nature of text. Basically your transformer embeddings. Right, and this pipeline is also a very flexible algorithm which can easily adapt to advancements in language models, clustering techniques, dimensionality reduction techniques, etc. So basically you can combine these different pipelines, right, in this pipeline, right? So you can have different, maybe if a new dimensionality reduction technique comes, a new clustering technique comes, so, or a new way of identifying word comes, you can put it into this pipeline. Okay, so that is what is the advantage over here. What he also says is that the class-based TF-IDF works quite well in extracting topic representation from cluster of documents without focusing on centroid-based extraction, which has its share of problems. Okay. He also says that doesn't mean that BERTopic should always be preferred over LDA and NMF. Okay. So BERTopic also has different types of topic methods like dynamic topic modeling over time. Okay. So LDA is much more easy to implement. It has quite a number of variations that may suit different use cases. But here, if you have if you don't have a GPU, then your embedding of these documents itself takes a lot of time compared to LDA. So what he says is that I believe that especially with topic modeling techniques, there will not be a single technique that will perform another in all use cases. So it again depends on your document, your use cases, where you have to evaluate which is a better method. Okay, which can give you useful topic representations. So that is what he has replied, which makes sense. Okay, so this was about why BERTopic when compared to LDA. Okay, now coming to the installation notes, when I tried to install this, I had this issue with NumPy. So again, I found out that in this BERTopic page, they beautifully put up FAQs where that issue is present. I am facing issues with NumPy. So I just looked at basically over here somewhere it was there. Yeah, wait, I saw somewhere over here that issues were presented. Yeah, NumPy gives an error. So I went into this particular thing. And when I looked at it, people have listed over here as what is the solution. And then I tried this particular configuration of Python 3.9 with NumPy 1.22 and NumPy 0.530. Basically, I created a new Conda environment, Python environment, and then I used this solution of first installing, using pip install the NumPy and NumPy library, and then installing your pip install BERTopic. And then I did not have any issues, because otherwise you might face an issue while installing BERTopic. Okay, I hope you find this video on BERTopic, a new topic modeling technique which makes use of your embeddings basically sentence transformers embeddings, and then your class-based creating clusters, and then class-based TF-IDF to create basically dense clusters and easily interpretable topics, useful for you. I'll be putting this particular code in my GitHub, and I'll be sharing the link to the GitHub. I'll also share all the other relevant links in the description of the video. See you in another video. Happy learning.